enjoying thinking about this presentation. I will try to talk clearly, but also cover a lot of ground. I'm grateful for the opportunity to talk about what ground penetrating radar can do in this concrete sawing and drilling world. What I'd like to do is introduce the GPR and how to use it. My name is David Cist. I'm the Chief Technology Officer of GSSI, and my background is in medical imaging and geophysics. My colleague Brett Caldwell and I will look forward to answering your questions at the end of the presentation. He has many years of experience using GPR to scan for concrete cutting. So first, we'll talk about what it is, and then what else it can be used for. We'll talk about why scan concrete before drilling and sawing anyway, and what other options are available for scanning. And then we'll go into details. So first, the definitions. You probably already know that radar stands for radio detection and ranging. The radar is simply something that detects an echo off the back of some object far away, and then gives you the distance. The GPR, ground penetrating radar, is simply a lower frequency, longer wavelength, lower frequency radar. That, because it's lower frequency and longer wavelength, can penetrate into the ground or into some material. When you walk onto a job site and drill a hole and cut concrete, you're trying to solve a puzzle. You may be using an as-built map or simply walking around looking at your junction boxes. In any case, what you're doing is you're trying to figure out something that you can't see into. And that puts you in very good company. For 50 years, GPR has been used around the world to do just that, to solve puzzles. We've been doing that in these pictures. I just have a few pictures here to show you. In China, to do search and rescue, radar looks through concrete to find living victims and to rescue them, which it did. It's also used by the police to look and find buried bodies. This next picture is simply showing you a TV show with our radar in the background. You'll recognize the Great Pyramids of Egypt. It was used to find a boat underground in front of one of the pyramids. It's been used to find the largest emerald in America and a woolly mammoth in Siberia. I would enjoy talking about how radar is now used for navigating for autonomous vehicles and for doing CAT scans of trees. There's so many different applications, and they're all connected to the same thing. And that is people who are trying to locate and dig into something and know what they're doing before they dig into it. Of course, that's true in archaeology, where our radar gets used around the world. Nobody wants to destroy these beautiful structures, and so everyone is trying to figure out a non-destructive way to see inside these materials. I have spent several years looking for lost cities in China and helped the National Geographic look into this pyramid with this robot, which turned out to be a disaster when the robot broke down on live TV. But in the end, GPR is simply doing a task that really can't be done any other way. For buildings, for example, in ancient structures where there are no as-builts, we are simply looking for some structural defect. This example is with some friends of mine in the Hagia Sophia, looking at the oldest dome structure in the world for 1,000 years. We also use radar, many people use radar, to map a path. So when you're cutting a line, you are mapping a path. And this is a larger example of that, where a radar is in front of this big truck, and every year they map a new path to the South Pole from the ocean. This is used to keep people safe. The driver is looking at a GPR picture like this all night long as he maps this path, constantly watching so that he doesn't run over something like this and have a very bad day. And so radar is used simply to map and plan paths similar to what you do. People don't generally dig to dress up in hazmat suits and dangle from buildings and suspend themselves under bridges. just for fun. They are trying to solve a puzzle, and they're doing it because there's really no other good way to do it. And GPR is a tool for concrete, for seeing concrete, and it's really no different from what I just described. You are seeing inside a structure that you don't want to destroy. You are trying to avoid some hazard, some safety hazard that could be fatal. And you're trying to maybe perhaps even decide whether you don't want to look into something at all and avoid a bad day. So when you look at this floor, for example, you walk onto a job site and you look at a floor. What are you doing? Well, if you're like Brett and like me, you're always trying to figure out what's down there, what you can't see. So you might grab the as-built plans if they exist. For old buildings, that's impossible. You might do a walking inspection looking for junction boxes. You might go under the floor and look at the ceiling, the underside, if it exists. And then you're going to cut. And most of the time, you're going to cut into structures that will have little difficulty. It might be easy, and it might be easy to find a place to cut. It might not even matter where you cut. Other jobs might be a little more complicated, and this is sort of a funny picture of just how complicated it can get. But in any case, you're going into a job site and you're trying to find where it's safe to cut. You're trying to find things that might be very difficult for your day. These blue lines, for example, are the post-tension cables, and the conduits are indicated in orange here. So in any case, what would be very helpful is to be able to know what you're about to hit before you go in. It could save somebody's life in the worst case, or it could just be very expensive in a different case. And that's what GPR does. For example, here, we use a radar and we can see junction boxes below the rebar mesh and radiant floor heating above it. And radar gets used all the time, all around the world for these purposes. So you can see pictures that can be very beautiful and complicated, 3D pictures. And the 3D pictures help you plan your hole. For example, here's this green cylinder, and you can, on a computer, plan exactly where to drill, or you can map it out on the floor like this. So this is an example of a markout that's typical, although fairly complicated. You can see the blue lines are the rebar mesh, and the red are going to be the post-tension cables. And the cutaway shows where the accuracy, and it reveals the accuracy of what we found. There are better ways than simply cutting into the concrete and looking for something that might be down there. We have, by the way, periodically poll questions that we'd love to ask you during the presentation, and here's one of them. Okay, so now I'd like to, now that I've shown you what GPR is and how it can be helpful for concrete, I'd like to show you some of the various other scanning options that are out there. GPR is not the only way to see inside something. There are other options. X-ray, there are ferro scanners that measure or map iron, or sensitive to iron, the iron in the rebar. There's ultrasound, which has been used as well for many years. It's sort of the first cousin of GPR. And there's infrared mapping. What we're not talking about are stud finders. So there are plenty of stud finders you can buy for $20 or whatever currency you're in, and find things through plaster walls. And they're great, and I have several. But if you're trying to cut into concrete, these will not work. They don't penetrate deep enough. X-ray is a marvelous tool. Here's an X-ray tube on the right, and here's an X-ray digital image of the marked out area on the left. It gives amazing pictures and can map out your conduit and your rebar and your post-tension cable very nicely. The pros and cons, the pros are it just gives fantastic resolution. It gives sub-millimeter resolution. And because of that, you can do crack detection and you can map subtle changes in the concrete. This is a really great tool. The cons are that it has radiation hazard. You would have to shut down your site while you're using it. You have to access both sides, since of course you need the X-ray tube on one side and the film on the bottom underneath. And sometimes that's difficult or not possible. And it's also very expensive. But it's a very useful tool, and people use it around the world for mapping before they cut or drill, especially in very tricky, highly complicated sites. There's also ferroscanning. Ferroscan simply looks at the rebar. It's great because it's a lower cost device. It's very easy to use. It's good for simple jobs of marking out bar. And it also gives rebar diameter, which ground penetrating radar cannot do. The problem is it only, of course, detects ferrous objects. It's not able to detect plastic pipe or PVC, and the penetration is not so good. So, but for shallow jobs, this is something you might want to have in your toolbox. Ultrasound is also very similar to GPR. It gives really great pictures, similar to GPR. One of the great things it can do is do faint delamination detection, which is hard for GPR. So any kind of air travel, it will show up and break the signal, which is good. It will detect cracks and voids. The cons is it's very slow and it's very surface dependent. So for many jobs, the surfaces are not good enough or not conductive enough for ultrasound to work very well. The next one is infrared. Infrared is used a great deal on bridge decks. I shouldn't say that accurately. It's not used often for bridge decks, but it can be used, and it can be very effective for bridge decks, partly because it gives such rich detail into what is down there. You have to do it right after sunset when the bridge is radiating heat and losing heat quickly, but the metal inside is retaining heat, or vice versa. So you can exploit the differences in temperature on a bridge deck. The problems is that it's only used in very special conditions where there's a heat change, and the penetration is not very deep. So GPR is sort of the last one of these. It's on the list. It's one of the most commonly used tools for marking out, partly because it's very fast, partly because, as in this example, it can be very small and get into really tight places. It doesn't only see metal. It can also see PVC. It can see thin wire. And there's enough penetration for typical jobs. So if you need to see 40 and 50 centimeters, GPR can do just fine for the thicknesses that are typical for slabs. It cannot do rebar diameter, and the cracks, if you're going to do crack detection, the cracks need to be fairly large. But other than that, it's a fairly effective tool, and the proof of that is it gets used effectively around the world. There are some very large companies that all they do in the US is do service projects to map the rebar for companies or for contractors who are going to drill and cut. Now let's look at how to analyze and interpret GPR data. This is fun because there are lots of, it's both complicated and easy, and I want to take some of the mystery out of it. So when you push a radar across the ground, across the top of your slab, you get these targets. If you've ever used a fish finder, you can see these little hyperbolas, the little hats, and they show up whenever you get close to a reflector and then go away from a reflector. So as you move the radar over the surface, you see a scan developing where you can see fairly complicated patterns, but typically the targets show up very clearly and you can map them and know where they are. So in this case, for example, these are some rebar targets and a PVC pipe, 2 PVC pipes, and you can see them very clearly in the signal. You can also do 3D, and so it's basically doing these lines many, many times and stitching them together to map out very subtle and complicated structures. Many contractors or many service providers don't do that. They simply mark and go. So they do a series of 2D lines, mark them on the ground. They don't need the fancy 3D parts. But for very complicated jobs, it's important to be able to have this option. We'll now look at a video. Jen Lighthall has put a video together for us on the basic use of GPR and how it works.
I'm Jennifer Lighthoff, GSSI's Marketing Coordinator, and I'm going to talk to you today about using a handheld concrete scanner. This is GSSI's mini XD system. Let's get started. We use the backup cursor, which is the yellow line on the screen. I just auto-gained the screen, which made the targets brighter. The type of surface that we are working with is slab on grade. Slab on grade is concrete poured over dirt, and you can tell there is a trench that was built, most likely for a pipe. If you look at the data, you can see that there is a target in the middle of the screen, which is the pipe. Looking at the data on our screen, you can see in the left-hand side, it is centimeters, and we set our depth to 50 centimeters down. If you look at the top of the screen, you can notice how the slab looks different. Well, if you pull your system back, you see where the trench starts on the screen, matches up with your lasers. Then, if you push it forward, again, your lasers match with the top of the screen where the trench ends. Then, let's pull it back to the middle of our target. Looks like our target, based on the screen, is about 18 centimeters down. Let's mark out some rebar.
Great, thank you, Jen. So you just saw how to mark out rebar without using any fancy 3D functions. You simply go back and forth, mark the tops of these targets, and then you can see where the rebar is. So that's the basic idea. We have several functions for helping you analyze GPR to make it easier. There is a focus tool which takes these hyperbolas and lets you see the rebar as they are, simply as dots. And that can be very helpful. I actually prefer to see the targets as hyperbolas just so I know exactly where the tops are and it's less confusing. And it shows more subtle detail. But you can see that it's not very difficult to scan, pull back, and see exactly where the rebar targets are, especially for straightforward jobs. There's another thing GPR is really good for, and that is finding voids under the concrete. So here's a classic void that's been left where the concrete wasn't able to get to a section under a rebar mesh. And voids light up very easily, especially if they're large. If they're very fine little cracks, or if there's been a crack or a delamination, it's more difficult for GPR, but they still show up. And then you can see middle way down, you can see the bottom of the slab. And then other targets below it. So actually this picture has some very rich detail that tells a lot of information about what's down there. And you don't need to be a huge expert to be able to tell what this picture is telling you. Here's another picture that shows the data where you can mark in the targets very clearly, but also to show pandecking, for example. And this is the metal support under concrete, under typical floors around the world. And pandecking shows up very clearly and cleanly. And you can often determine conduits and various things that are laid in the pandecking by subtracting out the typical pandecking pattern. So this is very useful for seeing your structure and understanding what's down there. This is one of the more subtle and important parts of ground penetrating radar, and this is where the service companies really are helpful. This is a scan, the same scan, but using a different polarization. If you take your antenna and you rotate it 90 degrees and push it along the surface, you get a different signature back from the radar scan. Look on the right. You can very clearly see that the rebar mesh at the top of the scan. You can see the slab at the bottom of the grade, the bottom of the slab at the bottom. But the targets that are in there are obscured by the rebar mesh. On the left, you see the cross-polarized view. It's the same scan, it's just using the radar at 90 degrees. It basically suppresses the amplitude of the mesh so that you have an opportunity to see the more subtle targets that are down below. This is often a picture that I think is very important to describe, because there is some training involved in radar. It's not completely simple, but I think the point is that you can see everything you need to see with a very little amount of training. Let's look at some case studies just to explain this further. So typically you would do what Jen Lighthall just did, and you would map out the various targets with your pen, pulling back over each target and marking it out. You leave a little bit of width for each target, because since radar cannot give you diameter, you need a little bit of width just to make sure that you don't hit anything. And then for large 3D sections, you can make these amazing maps of your bar and mesh. What you're trying to avoid are situations like this. On the right, you see some post-tension cable that exploded because it was hit. And on the left, this is how many people that I've talked to, cutters in our area, say this is how they find mesh, and this is how they determine the difference between mesh and pandecking and even post-tension cable, is they can look at the color of the sparks. This is not probably the way you want to do it, and these are the sorts of things that can go wrong and give you a very bad day. I've also had cutters tell me that they would, when they're cutting a door, for example, and they're going to cut through rebar, and there is no post-tension cable and there is no conduit, they just know it's rebar, that if they could scan the wall first and see that there is a rebar that's going right along their cut line, but maybe at a slight angle, you could have a very bad day by hitting the rebar and then suddenly having it bind, because you're cutting on one side of the bar and then suddenly it jumps to the other side. And so many people, many contractors and cutters use radar to be able to ask the owner, may I move this 1 centimeter to the right or the left to avoid a very long day? Typically, you have problems like this, which are easily solved. You can mark out and map out a duct, a track that you want to cut. You can see, for example, you know that there is going to be a conduit coming from these junction boxes. You want to cut this trench, and you don't want to hit the conduit. So this green line would be your cut line. The green line would show you that you can cut and remove material up until the red conduits, and then you might want to go more slowly and dig by hand around the conduits to avoid cutting them. This is also a really good example. You see the green trench line lines up exactly with one of the rebars on the bottom left. And that would be an example where if you could, you'd probably want to move your trench just a little bit to avoid lining up so carefully with that rebar. You would shorten the life of your saw if you had to cut through a long line of rebar, but you can also bind the saw and create trouble for yourself and for anyone else. So this is a typical and a beautiful example of how you would mark out a trench and be able to save yourself some time and money by not cutting things, and by going slowly where you need to go slowly and quickly where you can go quickly. Some sites are not so simple. So here's an example of radiant floor heating. This is a gorgeous picture of mapping out exactly what's where. And this would be an example that I would say is best left to a service provider and an expert who knows where things are and what to miss, and can understand where the cables are and the complications that a radar signal will show. Here's another example, a beautiful example of experts mapping out post-tension cable in the bridge structures in San Francisco, where they need to do a seismic retrofit and make changes in the bridge supports. This would be an incredibly scary thing to do without some knowledge or guidance of what's there. And this was done successfully with a very good company in California. And you can see the job is large and complicated, and you really can't do this any other way than using a radar. So just to show you a final good example, this is a concrete floor that is not incredibly complicated, but not simple either. You have conduit, you have some post-tension, and you're trying to make sure that you've got a safe place to drill. And this is a typical example that you could use and find out where you need to be. Sometimes jobs are so complicated that you might politely decline to take the job and say, this is too complicated, and many people have. Brett has examples that we can talk about in a few minutes of jobs that he has done, and they've decided, you know what, this site is just too complicated to safely drill or advise people where to drill. So we think maybe you should not drill at all. And that happens periodically. But either way, it's a tool and a method. GPR is a tool and a method for giving you the ability to see ahead of time to solve the puzzle that you're trying to solve about where to drill and where not to, and how to avoid a very long day. So I wanted to end our conversation with the ability for asking questions. If you have questions, please send it in the chat, and Brett and I will do our best to answer. Thank you. Anita, would you like to take over?
Yeah, thank you so much, David. And I will invite Brett, please, if you turn on your camera and microphone. First off, beginning the question time. Brett, if you can introduce yourself, please.
Hi, my name is Brett Caldwell. I have a long history with radar, actually. I was in the U.S. Army and did air defense radar before going back to university for geology. And then I ended up as a service provider doing ground penetrating radar with one of the largest concrete sawing and drilling companies in the U.S., working all across the U.S. with all the different construction types we have here, and was eventually the GPR field supervisor for the central U.S. And then for the last 3 years, I've been with GSSI in the geophysical market.
Okay, so thank you so much, Brett, and thank you for joining us to this question time. For all the attendees, like David said before, you have on the right part of the screen the chat. You can use it to write comments, questions, whatever you want. And using the time we have to the 4 o'clock, we try to answer all the questions that came up.
So
okay,
yes, go ahead.
Yeah.
Oh, before we go, I think it'd be helpful if I asked Brett some questions, since he has the experience in concrete cutting, of times that he's had to walk away from a job site because it was just too complicated, as I mentioned.
Yeah, so you'll typically run across this, especially in perhaps buildings with post-tension cables that are running along column lines. And what you'll have is several tendons coming in, or several bundles of tendons all coming in at the same column from different directions, sometimes with swoops where they're not running in a straight line. And then you also have all the reinforcement, the structural steel around that column coming out into the slab at the same spot. And there's been a lot of times where I've had to tell, or a few times at least, where I've had to encourage the general contractor or the electrician or whoever I may have been working with that, hey, we need to find a way to engineer around this problem rather than putting this hole exactly where you want to. Other times, you run into ducts of PVC piping that has conduit in it, kind of like the pictures that you showed, Dave, where because you maybe have a top mat of structural steel and a bottom mat and all that tubing running in between, you're just not able to safely find an area large enough for maybe perhaps the diameter hole that is needed for whatever the problem is that we're trying to solve. So those are the times where sometimes you just have to ask them, hey, we need to find a way to walk away from this and move it. And usually the engineers that you're working with are pretty open to that, because nobody wants to cut something important or get somebody injured by cutting into something that could hurt someone.
Okay, thank you so much. Right, I don't know if you want to ask him more questions, David?
Oh, I've got 1,000 questions, but let's see. We have one here that might be helpful to look at.
Yeah, I will be asking to you. I don't know if you have more questions to Brett. One attendee asked us, what GPR industry certifications are available for GPR operators? So,
I mean, David, unless you want to ask this, I know CSDA, Concrete Sawyers and Drillers Association in the U.S. has a certification that they've been working on for some time and is available in the United States. Different manufacturers, we offer a certification when you attend one of our courses. With the purchase of any of our systems and domestically, we provide access to classes in that particular application and using that particular product here in the US.
So I don't know how it works in Europe. I have heard that people simply can buy a GPR and then do scanning and do the best they can. So I'm not sure there are certifications, but training would be, it's always a very important part of what we do. We offer free training, in fact, and hours of YouTube video for training people, because we don't want our equipment to be used poorly. And we care about the GPR industry in general, not just our equipment, to make sure that people use it safely.
Okay, and one question, GPR normally is purchased or is rent sometime with an operator?
Both. So typically, so I think it's different in Europe than it is in the US. Many contractors who are building new buildings or renovating old buildings, they don't want to have to be an expert in GPR in order to know where they are telling their cutter to dig or drill or cut. And so they'll often simply hire a contractor. It might be a shop that only has 1 or 2 people, or it might be a company that has 400 people, as also exists in the US. And they go around the country and charge for a mark out and certify that the mark out is accurate. So those companies will purchase a radar and then go around offering the service. Many other cutting companies buy their own radars in order to be able to see what's down there and be able to make sure that the service they're offering for cutting is safe and effective. There are rental options available, but typically people will buy their own. In the scheme of the cost of drill bits and tools, it's expensive, but it could save you having one very bad day, which would pay for it right away.
Mm-hmm. Thank you, David. I don't know if you want to add something, Brett?
No, David basically hit, I think, everything. Yeah.
Okay, hey, perfect. I continue with the questions. Another attendee, well, some attendees say hello from Vermont, David and Brett.
Yeah, we're both just down the road, so New Hampshire and Western New York here.
And another attendee sent us a question that says, what is the accuracy? For example, depth to rebar in reinforced concrete, thickness of concrete slabs? Yeah,
that's a great question. And I didn't want to get people bored with details, but this is an important detail. So accuracy depends on how carefully you set up your project. So for example, when I showed you these these hyperbolas, these little hats, these targets that you see when you go over rebar. You can get back and forth, as Jennifer showed you, you can get the top of the rebar very, very accurately, maybe within a couple of millimeters. So that is very accurate. The back and forth and getting the exact position of the top of the rebar is always highly accurate. It's actually, the hard part is the marking, because the marking of chalk is less accurate than the radar. What's not accurate is knowing the rebar diameter. So you have to leave space around the center point to make sure you don't cut. So that's not accurate for radar. And we don't always know the size of the object. Of course, if it's a beam, we have a huge platform and you can see very accurately the width of the beam, but the diameter of the object is not easy to determine. So that accuracy is not something that we certify or can promise. Typically though, people know what their rebar diameters are, and so they leave allowance for that. In terms of getting concrete thickness, again, that can be highly accurate. It can be probably, we can say 1% of the thickness of the slab. So if the slab is 50 centimeters, it could be accurate to a millimeter or even better. But that very much depends on picking the right velocity of the medium. And this gets into some technical stuff that I'm not sure is so helpful, but there is a way to determine the velocity of the radar signal very accurately. And so you can achieve those. If you don't know what you're doing, you could be off by a great deal. So if you need to know the depth of something, you need to accurately calibrate, which is easy to do.
And the good news is for concrete, it's somewhat homogeneous, across, it's roughly in the same dielectric range. So you're going to be in the ballpark a lot of times compared to geophysical studies where the materials can vary in velocity greatly. So, I mean, at my previous company, we would usually say we were accurate within 1/4 to 1/2 an inch in vertical measurement when we were doing our scans. And there's several ways to calibrate the GPR. A great one is known depth of slab, and you can adjust your depth based on that. And then everything within that slab, you'll have a pretty accurate depth for.
Thank you so much to both of you. I will continue with the questions. Okay. Another attendee asked us, is to David, but Brett, you can help if you want to. Says, David, can you elaborate a bit more how cross polarization can help to detect deeper objects?
Yes, and it's a great question, and I only touched on it quickly. So I was hoping somebody would ask me this question. Here is some rebar, for example. Here's a section of rebar. It's been cut, and you can see how it was cut from a drill hole.
David, I will put you.
There we go. Thank you. And so this rebar is a typical rebar that you might see. Now imagine you're taking your radar and you're going across the rebar like this. The antennas are actually radiating this way, back and forth. And the radiation pattern of the antenna, when it's going in this direction and it radiates onto this bar, it's exciting all the electrons in this bar a great deal. And so you get a huge reflection back to the radar because your polarization of your antenna is the same direction as the radar. So what happens is you get a big reflection off of that bar. If you now go perpendicular instead to that bar, remember the radar is going back and forth like this. So if you're going perpendicular to that bar, like that, for example, instead of like this, if you're going perpendicular, the radar signal is going this way, and very little of the electrons are exposed to that radiation pattern. And so you get a very much weaker reflection coming back to you from that bar. And normally you would think that that's kind of stupid. Why would you do that? Of course, you don't want a weak reflection, you want a strong reflection. But for thin wire, for rebar mesh at the top of your slab, there are many times when you don't actually care about the rebar mesh. You're going to cut through it anyway. It's not structurally important necessarily. And so you just want to see what's down below it. But the strong signal that you're getting back from the top mesh is actually hurting or harming your ability for the penetration, the radar penetration, to see much below it, because it's creating so much strong signal. And so what trick people use, and it's great, is you go across this way. And so it weakens the signal on the top mesh, and it lets you, saves the signal for what's below it. And so you can see further down. So if you want to ask a further question, you can. I don't know how to make that a simple answer, but basically it's the direction of the bar when it's lined up with the direction of the antenna is the reason for doing cross polarization. Brett, do you want to answer more?
I was going to say, and when you say antenna, it's actually the bow tie antenna inside of the actual, what is typically referred to as the antenna. Do you have a Palm XT handy by any chance, David?
I don't, but I have a bow tie.
There you go.
This is actually a friend of mine made me a bow tie antenna. This is a bow tie. So the antenna, the radiation goes out to the end of the signal and comes back. And so this bow tie then, when it's aligned with the rebar, it's radiating the signal back and forth this way. And that's what is the signal that's giving you what you need in order to get the maximum signal off of a metal object.
Yeah,
and we have much more to say. So go ahead, Brett. See what
I was going to say, we have our Palm XT antenna, which is basically, what is it, 4 inches by, or 5 inches by 5 inch box, has a survey wheel coming off the back. And that survey wheel has a hinge that allows you to just click it and turn it. And that way you can run it perpendicular, within a second or two. Compared to doing it the old way, with the old analog hand antennas, it was a lot more complicated, or a little bit more complicated at least.
So we try very hard to make it easy for experts to rotate their antenna and do the same scan to make it easier to see underneath the rebar mesh.
Okay, thank you so much. It's a very interesting answer to the question, very interactive. So thank you so much, both of you. We have more questions, so I will continue making you questions. Another attendee asked, is there any case where PT cable hiding perfectly under rebar? Can 2D and 3D scan catch PT cable? Yes,
and that's why you would do a 3D scan, or you would do a larger section. You saw, for example, in the pictures that I gave you, usually people just need to cut or drill a hole in a very specific area. But the reason you do the larger survey is you want to actually have a feeling for what is down there. Conduit often bends towards a junction box. Conduit often you can figure out that it's conduit because it's changing direction. Whereas rebar mesh is almost always perpendicular. It always has this regular spacing. It might overlap, but you can figure that out. So you're actually the expert. So what radar is hopefully is just a tool to give the expert the information he needs to find what's down there and to understand what's down there. So go ahead.
I was going to say, and when you're working with, a lot of times with new construction where the side of the slab is exposed on, say, a high rise, you can walk the outside and find those grout holes at the ends, or even the exposed post-tension caps at the end, and then use your rebar or your radar to work your way back to the actual area of interest that might be 10, 15 feet away. That post-tension is going to be at regular spacing. If you have access to the as-builts, it'll actually tell you what the spacing should be. And so when I walk onto a job site, or when I would walk onto a job site, I'm not just going to scan that 2 foot by 2 foot area that they want to put a hole in. I might take it out real quick and walk it along the floor for 30 feet just to get an idea of the pattern of both the rebar and the post-tension cable and look for anything that's outside that pattern. It could be conduit, or it could be a PT cable that they put in there that shouldn't have been, which happens every once in a while. So you always want to, when you first walk onto a site, get a picture for the overall site, kind of a holistic view, and not just your little specific area of interest.
So the answer to the question is yes, PT cable can be hidden under rebar. And that's why you must have a bigger picture or a larger picture to kind of figure out where these things are. Because if you do one scan, you have one target and you have a target underneath it. It may be a multiple reflection of the target above it. It may actually be hiding the PT cable that's right underneath. but it can't hide for long. So the PT cables move and they change depth and they undulate, whereas the bar doesn't. So you can usually figure it out.
Okay, thank you so much. You are very, very clear with your explanations, so thank you. I'm not the only one that are saying that attendees are saying too, so thank you so much. I continue with the questions. We have like around 10 minutes to end the webinar. And another question, how often do GPR service providers make mistakes?
I can start with an answer and then we'll give it to the expert.
Yeah.
I've actually asked a lot of people that, and I've been on a lot of job sites and asked a lot of service providers, how often do you hit something or you mark out something that's wrong? And many service providers will say 99.6, 99.5 times out of 100, I'm accurate and no mistakes happen. But it's the 0.5% that do happen that are very expensive or can be very expensive. And so it's almost always highly accurate, especially for someone trained. If they're not trained, that number, of course, goes up. Brett, do you want to follow on?
Yeah, when I was doing it, I think I kept track through like 3,000 scans that I'd done. And I think I told you yesterday, the day before, I'd had 2 hits. One was a post-tension cable that was running out of pattern, not in the as-builts, and it wasn't actually under tension. So because of that, I identified it as rebar, and it was cut, and luckily nothing happened, other than there was a piece of post-tension cable in the core that came out of the hole. The other time was a low voltage line for a fire alarm system that was running in basically in pattern with the rebar around it. And so it was a mistake that could be made. It wasn't producing enough electricity to be picked up by EM. But again, my accuracy and that of my scanners that worked for me was well over 99% accuracy. I mean, like 99.9 something percent accuracy, considering the thousands of scans that we were doing every year. But that does depend by company and the amount of training that they put into their folks before they send them out into the field to do the scanning by themselves.
Maybe I could amplify or go on to that a little bit. There are jobs and mark out tasks that you really should only leave to the experts. But there are most of the tasks can be done without being a huge expert. With a little bit of training, you can understand where the site is easy and where it's complicated. And I think the judgment would come in knowing when the job is more complicated than your ability and knowing when to call someone in.
Yeah, I mean, I would always push the contractor that we were working for, cut through clean concrete. It's easy, and that's a really easy thing to do with GPR, is to find an area with absolutely nothing in it. So as long as they're somewhat flexible to move that hole or move that cut line by even a couple inches, you can avoid pretty much any hazard whatsoever or any risk, as long as you're doing it that way. It's when you have a 16-inch hole or a 36-centimeter hole that needs to be put exactly here that you can run into issues like that.
Okay, thank you so much again. Some attendees said impressive accuracies. So I continue with the questions. We have like time for 1 or 2 more questions and we will end the webinar. And another question is, how easy is to learn to be good enough to mark out simple jobs?
That's a good question. Maybe Brett should be answering this question. As I said, we have training classes for this, and to be proficient, you really just, and I've had lots of cutters who just buy it and start using it. So to do simple markouts, it's really simple, but to know what you're doing and to have 99.9% accuracy, Brett can tell us how long that training requires.
Yeah, I mean, we would send our people to GSSI for the manufacturer's training, which was typically 2 to 4 days, depending on what we were sending them to, which classes. And then we would do a 2-week training session in-house with them, kind of as a group of new hires. And then after that, we would have them shadow somebody in the field for at least a month. And then usually we would kind of cut them loose after 2 months, roughly, of nothing but training. That was on the professional side. To mark out a very simple area or just do complete hazard avoidance where you're avoiding target or anything embedded altogether, that's really quick. You could do that after the manufacturer's training, because all you're doing is identifying a clear spot to cut with nothing in it. It's when you're trying to differentiate between post-tension and rebar and conduit and anything else that might be in there, that's what takes a little bit more time.
Mm-hmm. Okay, thank you so much. So I will ask you the last question and then ask you for some conclusions and end the webinar. The last question is, it is safe for the GPR user to be exposed to radar for long periods of time? And if so, how can they protect themselves?
That's a great question. We get asked this question all the time. Mm-hmm. And the good news is that most people have one of these. And most people put them right about here. The ground radar is 100 times less powerful than this device. Mm-hmm. And so you could spend a lot of time with the radar right up against your face, and it would be 100 times less harmful than your cell phone. Most people don't use radar that way. So the further away, I think it's very safe to say that there is no harmful radiation from a radar. You could use it all the time. Your microwave oven is much more powerful and harmful.
Okay, thank you so much, David. I think that you are agree, Brett. So I will ask you last question because we have like 2 minutes. What are some common mistakes in analysis?
Okay, that could be, we could take an hour. Let's see, let's do it in 2 minutes.
Another webinar.
That's right. Invite us back in 2 minutes. Common mistakes. Well, actually, Brett, do you want to do this in 2 minutes? Because
misidentification of targets is the big one when you're having to cut through an object. Oh gosh, yeah, being completely off with your dielectric setting for the radar. Therefore, you're getting bad vertical resolution. Mm-hmm. And all these things, they're relatively easily correctable. Mistakes shouldn't happen as often as sometimes they do. I don't know, David, what else do you have?
No, I think common mistakes, and it's really easy to do, is relying on one profile, one scan, and think you have the answer. You really need to have several scans to confirm and piece together the puzzle. Remember, you're solving a puzzle, so you're not just using one puzzle piece to solve the puzzle. You need to piece several things together to get the right answer.
And we've talked several times about you're always hitting objects perpendicular. People have to remember that when they're doing a scan, you don't just go in your X and your Y. You want to go across diagonally and at oblique angles to catch objects that might not be running perfectly parallel or perpendicular to the travel of the rebar. That's where you can catch your conduits, that are sometimes less visible in the radargram compared to your metallic objects. And it's taking the time to be thorough when you're doing it that can cause, or not taking the time to be thorough that can cause some easy mistakes to happen.
Okay, thank you so much. So now, yes, we are ending the webinar, but I don't know if you want to say something to conclude, to close the webinar.
I think just to thank you and thank the IACDS for the opportunity to discuss this. GPR is a fun topic. You saw from the first pictures that we could talk for a long time about all the other really interesting applications that are there. But concrete scanning is our major business. And yes, there are things that might be more cool for archaeology and for finding buried bodies. But this is a really important field, and it's very important for ensuring people's safety and the structural safety of the building. So I'm grateful for the opportunity.
Yes, thank you very much.
for our part, thank you so much for your time, for your effort. I think it's a very, very great and interesting presentation. I will put your contact details on the screen. And all IACDS webinars are recording, but they are only available free for our members. But if somebody wants to see it again or something like that, you can write to us. Or if you want to contact with David, just you have your contact on the screen. And thank you so much, everybody. We hope to see you in another IACDS webinars. We hope you find it useful. I think yes, seeing what people are saying on the chat. So thank you again, and have a nice afternoon.
Thank you, Anita. Bye.
Thank you all.
See you,
Bye.
Brett.